Hello, my dear friends. This is Bandi Srinivaslu from My Physical Science Guru. New syllabus, 10th class, first lesson chemical reactions and equations. What happens in a chemical reaction? In a chemical reaction, chemical change occurs. Chemical change is equal to chemical reaction. Substance is used up or disappears, new substance is formed. Different physical and chemical properties are seen in new substances. Chemicals react to change. The chemicals in a chemical reaction are elements or compounds. They react when combined or broken down. Do you remember the difference between an element, a compound, and a substance? Chemical reactions are processes that happen when substances, things combine together to create new substances. During chemical reaction, atoms and molecules in the substances change and rearrange themselves to form different substances. They are called products. Oxidation, fixation, fermentation, hydrolysis, combustion, catabolism. These are the indications of chemical reactions. Oxidation is a type of chemical reaction that happens when substance loses electrons, for example, rusting of hammer. Fixation refers to the conversion of an element or compound from one form to another through a chemical reaction. Fermentation is a process that happens when we use tiny living things called microorganisms to turn sugar into other things. Souring of milk is an example. Hydrolysis is a chemical reaction that happens when we mix water with something else, break down food through digestion is an example for hydrolysis. Combustion is a chemical reaction that occurs when fuel combines with oxygen in the air and is ignited by heat. Setting fire is an example. Catabolism is a process that breaks down molecules into smaller ones, releasing energy in the process. A decomposition of an apple is an example. అనగా ఆక్సిడేషన్ తుప్పు పట్టడము, ఫిక్సేషన్ కిరణజన్య సంయోగ క్రియ, కిణ్వ ప్రక్రియ, జీర్ణక్రియ, దహనము, అదేవిధంగా డీకాంపోజ్ విచ్ఛిన్న క్రియ, ఇవన్నీ కూడా కెమికల్ రియాక్షన్సే అనగా రసాయనిక చర్యలే. There is an evidence for chemical reaction. One is color change, second one is precipitation reaction in which insoluble solid is formed, bubbles or gas formation, heat is produced or absorbed. These are the indications of chemical reactions that you can see here in this picture. So color is changing during chemical reaction. Whenever a substance is added to something, gas is released and heat is produced, or precipitation, yellow color precipitate formation, insoluble solid is formed at the bottom. These are the examples of chemical reaction evidence. Matter is neither be created nor destroyed. Atoms in a chemical reaction, they are rearranged, some atomic bonds are broken and some new ones are made. They are neither be created nor destroyed. This is law of conservation of mass. In a chemical reaction, the total mass of the substances before and after reaction remains the same. దట్ మీన్స్ రసాయనిక చర్యలో ముందు ఉన్నటువంటి రియాక్టెంట్స్ రసాయనిక చర్య తర్వాత ఏర్పడినటువంటి క్రొత్త పదార్థాలు సమానంగా ఉంటాయి. దీన్నే లా ఆఫ్ కన్జర్వేషన్ ఆఫ్ మాస్ అంటాం. కెమికల్ రియాక్షన్ యాజ్ ఫాలోస్: A plus B gives rise to C plus D, where A plus B are reactants. After reaction, new substances are formed. C and D are called products. Whenever this is represented by symbols, the chemical reaction becomes chemical equation. The quantity of elements and their atoms remains the same before and after a chemical reaction. The chemical reaction can be represented with a chemical equation. 2H2, 2 is the number of molecules. O2, 2 is the number of atoms, gives rise to 2H2O. Here on the left side, 4 atoms of hydrogen, 2 atoms of oxygen. On the right hand side, 4 hydrogen atoms and 2 oxygen atoms. This is what is a balanced equation. Chemical formula versus chemical equation. A chemical equation tells the story of a chemical reaction. 2H2 plus O2 gives rise to 2H2O, where 2H2O is a chemical formula. 2H2 plus O2, an element in a pure substance that cannot be broken down into new one. A compound, chemical formula is a compound is a combination of pure substances. A chemical reaction story: 4 atoms of hydrogen react with 2 atoms of oxygen. They are the reactants. They yielded 2 atoms of water. Water is the product or end result. Chemical reaction as follows: methane plus oxygen gives rise to carbon dioxide and water. CH4 plus O2 gives rise to CO2 plus H2O. The products contain the same atoms as reactants, and there is rearrangement of atoms. Chemical equation gives the information about state, physical state or form: solid, liquid, gas, aqueous. CaOH taken twice, which is in solid state, 2HCl, which is in gaseous state, calcium chloride CaCl2 in solid state, and water is in liquid state. Chemical equation gives us some information. First one, identities of the reactants and products, relative amounts of the reactants and products, physical states of the reactants and products, and stoichiometry. Let us try to balance the following chemical equation. Fe plus H2O gives rise to Fe3O4 plus H2. Step 1. To balance a chemical equation, first draw boxes around each formula. Do not change anything inside the boxes while balancing the equation. Step 2. List the number of atoms of different elements present in the unbalanced equation. First of all, write the symbol of the element, number of atoms in the reactants on left hand side, number of atoms in products or right hand side. Ion, there is only 1 on left hand side and 3 on the right hand side. Hydrogen, 2 on the left hand side and 2 on the right hand side. Oxygen is 1 on left hand side and 4 on right hand side. Therefore, this is not a balanced equation. Then go for that. Step 3. It is often convenient to start balancing with the compound that contains the maximum number of atoms. It may be a reactant or a product. In that compound, select the element which has maximum number of atoms. Using these criteria, we select ferric oxide Fe3O4 and the element oxygen in it. There are 4 oxygen atoms on the right hand side and only one on the left hand side. To balance oxygen atoms, in reactants 1 oxygen, in products 4 oxygens. To equalize the number of atoms, it must be remembered that we cannot alter the formulae of compounds or elements involved in the reaction. For example, to balance oxygen atoms, we can put coefficient 4 as 4H2O and not H2O4. H2O4. Now the partly balanced equation becomes Fe plus 4H2O gives rise to Fe3O4 plus H2. Step 4. Fe and H atoms are still not balanced. Pick any one of these elements to proceed further. Let us balance hydrogen atoms in the partly balanced equation. To equalize the number of hydrogen atoms, to make the number of molecules of hydrogen as 4 on the right hand side. Therefore, 8 4H2O 8 in the reactants, and in the product side 2 into 4, that is 8. Step 5. Examine the above equation and pick up the third element which is not balanced. You find that only one element is left to be balanced, that is iron. That is, in reactants it is 1, in product side it is 3. Therefore, in reactant side we have to multiply with 3. To equalize Fe, we take 3 atoms of Fe on the left hand side. That becomes 3Fe plus 4H2O gives rise to Fe3O4 plus 4H2. Step 6. Finally, to check the correctness of the balanced equation, we count the number of each element on both sides of the equation. 3Fe plus 4H2O gives rise to Fe3O4 plus 4H2. Balanced equation. The number of atoms of elements on both sides are equal. This equation is now balanced. This method of balancing chemical equations is called hit and trial method, as we make trials to balance the equation by using the smallest whole number coefficient. Step 7. Writing symbols of physical states of elements and compounds. Does this equation tells anything about the physical state of each reactant or product? No, information has been given in this equation about their physical states. To make this a chemical equation more informative, the physical states of the reactants and products are mentioned along with their chemical formulae. The gaseous, liquid, aqueous and solid states of reactants and products are represented by notations G, L, AQ and S respectively. The word aqueous is written in the reactant side. So this equation 3Fe, that is solid, 4H2O, that is gaseous, Fe3O4, that is solid, and 4H2, that is gas. Usually physical states are not included in a chemical equation unless it is necessary to specify them. Sometimes the reaction conditions such as temperature, pressure, catalyst, etc. for the reaction are indicated above and or below the arrow in the equation. For example, CO2 gas plus 2H2 gas in the presence of 340 atmospheric pressure gives rise to CH3OH, that is methanol liquid. 6CO2 plus 6H2O in the presence of sunlight absorbed by chlorophyll C6H12O6 plus 6O2 aqueous. Types of chemical reactions. First one, synthesis, that is chemical combination. A plus B gives rise to AB. Two or more substances join and form one single substance. Decomposition reaction. AB split into A plus B. One compound breaks down into two products. And third one, single replacement reaction, that is displacement reaction. AB plus C gives rise to AC plus B. Atoms of an element swap with atoms of second element in a compound. That means one element replaces the element of other compound, forming new substances. And fourth one, double replacement reaction, also called double displacement reaction or double decomposition reaction. AB plus CD gives rise to AD plus CB. Positive ions exchange between compounds, and this is called a double replacement reaction or double displacement reaction or double decomposition reaction. Examples for types of chemical reactions as follows. 2H2 plus O2 gives rise to 2H2O. This is a chemical combination reaction or synthesis reaction. One more you can tell, 2Mg plus O2 gives rise to 2MgO. Then decomposition reaction, also called analysis reaction. Example, 2NaCl gives rise to 2Na plus Cl2. And third one, single replacement reaction, or you can say this is displacement reaction. Fe plus CuSO4 gives rise to FeSO4 plus Cu. And fourth one, double replacement reaction. Example, NaCl plus AgNO3 gives rise to NaNO3 plus AgCl. Fifth one, that is combustion reaction. C3H8 plus 5O2 gives rise to 3CO2 plus 4H2O plus heat. And this combustion reaction, the fuel burns in oxygen, gives carbon dioxide and water with the release of heat energy. Whenever a chemical change occurs, we can say that a chemical reaction has taken place. This is the best example for chemical combination reaction. Here, magnesium ribbon is burned over the Bunsen burner flame, and white dazzling brilliance you can observe that burns with more illumination. Be careful while doing this experiment. See this activity of chemical combination reaction. Take a small amount of calcium oxide or quicklime in a beaker. Slowly add water to this. Touch the beaker as shown in the figure. Do you feel any change in temperature? Yes, it is little bit hot, and it is a exothermic reaction, formation of slaked lime by the reaction of calcium oxide with water. Decomposition reaction. There are three reactions here in this slide. First one, electrolysis of water. That is, water is decomposed into hydrogen and oxygen gas by passing electricity. This is called electrolysis. And in second one, that is FeSO4 gives rise to Fe2O3 plus SO2 plus SO3. This is a decomposition reaction in which ferrous sulfate crystals are split into ferric oxide and sulfur dioxide and sulfur trioxide gases. This is one reaction. Another one, third one, that is when lead nitrate is heated, nitrogen dioxide brown color vapors are formed with the release of oxygen gas. So these are the three reactions or decomposition reaction in which a single substance split into two or more substances. And third one, displacement reaction, also called replacement reaction. Here you can observe the conical flask containing zinc crystals when added with dilute sulfuric acid or hydrochloric acid, formation of hydrogen gas by the action of dilute sulfuric acid on zinc is the example for displacement or replacement reaction. Zn plus 2HCl gives rise to ZnCl2 plus H2. This is displacement reaction. One more displacement reaction you can observe here, that is iron nails dipped in copper sulfate solution. An activity follow. Take 3 iron nails, clean them by rubbing with sandpaper. Take 2 test tubes marked as A and B. In each test tube, take 10 ml of copper sulfate solution. Tie 2 iron nails with a thread and immerse them carefully in the copper sulfate solution in the test tube B for about 20 minutes. Keep one iron nail aside for comparison. After 20 minutes, take out the iron nails from the copper sulfate solution. Compare the intensity of blue color of copper sulfate solution in test tube A with test tube B. Also compare the color of the iron nails dipped in the copper sulfate solution with one kept aside. Iron nails and copper sulfate solutions compared before and after the experiment. Iron nail turned into little bit red color and the solution turns from blue color to green color. Fourth one, double displacement reaction. Activity 1.10. Take about 3 ml of sodium sulfate solution in a test tube. In another test tube, take about 3 ml of barium chloride solution. Mix the two solutions. What do you observe? You will observe that a white substance which is insoluble in water is formed. This insoluble substance formed is known as a precipitate. Any reaction that produces a precipitate can be called as a precipitation reaction. Na2SO4 aqueous plus barium chloride aqueous gives rise to barium sulfate precipitate plus 2NaCl aqueous. This is the chemical equation. Balance a chemical equation. Review law of conservation of mass. The mass of atoms remains the same before and after chemical reaction. Reactants and products, they make up a chemical reaction and are represented in a chemical equation. Atoms are neither destroyed nor created, they shift from one substance to another. This is what is called a law of conservation of mass. A chemical reaction can be decomposition, synthesis, that is combination, single replacement, that is displacement reaction, or double decomposition or double displacement reaction or double replacement reaction. 2H2 plus O2 gives rise to 2H2O. What type of reaction is this? Corrosion. When a metal is attacked by substances around it, such as moisture, acids, etc., it is said to corrode, and this process is called corrosion. The black coating on silver and the green coating on copper are other examples of corrosion. Corrosion damages or causes damage to car bodies, bridges, iron railings, ships, and to all objects made of metals, especially those of iron, that is called rusting. Corrosion of iron is serious problem. Now look at the pictures. That ship is rusting and car body is rusted, and corrosion of copper and corrosion of silver you can observe clearly. Next is rancidity. When fats and oils are oxidized, they become rancid and their smell and taste change. Usually, substances which prevent oxidation, called antioxidants, are added to foods containing fats and oil. Keeping food in airtight containers helps to slow down the oxidation process. In this picture, you can see how rancidity occurs. Rancidity means ముక్కిపోవడం. ఆ విధంగా వస్తువులు ముఖ్యంగా నూనె క్రొవ్వులు ఎక్కువ కాలం ఉంచినప్పుడు అవి చెడిపోతాయి. దీన్నే ర్యాన్సిడిటీ అంటారు. దిస్ ఈజ్ కాల్డ్ స్పాయిలేజ్ ఆఫ్ ఫుడ్. థ్యాంక్ యూ. థ్యాంక్స్ ఫర్ వాచింగ్ మై ఫిజికల్ సైన్స్ గురు. లైక్, షేర్, subscribe my physical science guru. Thanks for watching. This is Bandi Srinivaslu from